Okay, so then let's talk about FCP today. We have another protocol in CHAN, right? That is FCP, which is fiber channel protocol. Okay, and in FCP, first we'll talk about topologies. Okay, fiber channel topologies. So topology is nothing but it is a kind of just architecture or connectivity method. How we'll connect all the devices. I mean, how we'll form a network by using fiber channel switches and all. Like we do have a network topologies, right? The same way in fiber channel network also we'll be having different topologies. So we'll use we'll select the one of the topologies available in order to build your fiber channel network. So basically there are three types of topologies, three types of fiber channel topologies. First one is point to point. Second one is FCAL, that means fiber channel arbitrated loop, and third one is switched fabric. Okay, these are the three fiber channel topologies available. Okay, you can use any one of them in order to build your fiber channel network. Okay, just like how network team is building LAN network, we can build a SAN network by using any of these topologies. So let's talk about each and every one. First, let's start with point to point. So if point to point is the simplest fiber channel topology network where two devices will be connected to each other directly. Like there will be no fiber channel switch or nothing involved in between these two devices. Let's assume this is our server, okay, and this is our storage, so that we don't need any mediator in between them. This is just a fiber channel cable. We'll connect one end of the fiber channel cable to the server HPA. I told you, right, in FCP on server end we'll use HBS, and storage end we'll use fiber channel adapter. Okay, this is a fiber channel cable. Okay, this is a fiber channel cable, and here we'll be having HPA. So with HPA only, we can connect our fiber channel cable to the server HPA. The same way, we'll be having a fiber channel adapter on storage end. This is our fiber channel adapter FCA. Okay, that is how the point-to-point topology will be. Only two devices will be able to communicate with each other. This is a not a dash, Shrikant. Dash is means uh, that is different. Like JBoards will be involved. If you are talking about dash, JBoards will be involved directly without any storage and all. Like for example, your PC, you can say it as a dash. Okay, this is a fiber channel topology. This is not a NAS or DAS. This is a part of a SAN only, but it is point to point. Only two devices will be able to communicate with each other directly. It might be server and server also. We can say that you can do a connection like that. Server, server. Okay, this is a point to point topology. Let's So point to point connectivity is a simplest fiber channel configuration where two devices are connected directly are directly connected to each other as shown in the figure. See here also two devices, they're connected to each other directly, right? This configuration provides a dedicated connection for data transmission between the nodes. Like there will be a link, I mean, there will be a connection. By using this connection only, these two devices will be able to share the data between those two nodes. Okay, this configuration provides a limited connectivity as only two devices can communicate with each other. So in point to point, the limitation is you can only two device, you can place only two devices, because this is a one end and second end, right? You cannot place more than two devices in point to point connectivity. If you want to connect more than two devices, then point to point will be not a ideal solution for you. You need to go with other two topologies. Okay, point to point is only if you have two devices in your data center, like only one server and one storage, something like that, then you can implement point to point instead of involving switches and all in the middle. Okay, so it will reduce your cost. For example, if you have multiple servers and you want to connect them to a single storage, then it is you can't do point to point. You need to use uh, fiber channel switches in between, so that it will be not a point to point topology. Okay, so yeah, only two devices will communicate with each other at a given time, and it cannot be scaled to accommodate large number of network devices. Like, so later you want to add, you want to connect few more servers to your storage array, or later you bought another storage array and you want to connect it to servers. Then if you implemented a point to point, then it is not possible to scale means increasing the number of servers and storage arrays. It is not possible if you implemented point to point. Then you need to change your entire topology. You need to implement either FCAL or switched fabric to scale the network. But if it is a point to point, only two devices, not more than that. Okay, it is a simple thing. You don't need to put a lot of effort, and it is not that complex. It is very easy to configure. Okay, second one, FCAL. FCAL means fiber channel arbitrated loop. So here in FCAL, all devices will be connected in a loop. Okay, if all the devices will be connected in a loop, like a server or storage, again server, hub or switch, whatever it is, whatever devices be will put in FCIL topology, everything will be connected in a loop. Okay, for example, my server want to communicate with this storage, it has to go through, it can't communicate, it will, I mean, my server will be not able to communicate with the storage directly. Okay, it has to go through loop. For example, my server wants to communicate with this hub, again it has to pass that request through these two storages. Like that, I mean, the data traveling will be happen in a loop. It will be not like it can connect to, I mean, any device can communicate with the other devices directly. It is not possible in a FCAL topology. Okay, that is what here they are saying. All devices are connected serially in a loop. They have given some example of networking topology, like token ring network topology will be there. It is similar to the token ring. Okay, every device has a transmitter and receiver. You know, right? In fiber channel, we'll be using HBS and FCS, and each HBA and FCA will be having transmitter and receiver. To With the help of transmitter and receiver only, they'll be able to receive the data and transfer the data to other devices over fiber channel network, right? That is what they are saying. Only two devices can communicate at a time. Rest are blocked. Okay, rest are blocked. So this is called blocking technology. Oh, sorry. Yeah, so only two devices can communicate at a time. Yeah, rest are blocked. Okay, that means, for example, when my server, for example, this device is communicating with my second device, when these two are communicating with each other, remaining three devices will be in blocked state. That means they will be not allowed to perform any kind of IO operations. Okay, for example, if you have a 10 devices connected in FCAL topology, only they can able to communicate with each other, but at a time only two devices will be able to establish the communication. Okay, only two devices will be able to communicate with each other. Remaining devices will be there idle. Once this communication is done, then uh, another two devices will communicate with each other. Like everyone has to wait for its turn in FCAL. Okay, the failure of one device can cause a break in the link. For example, if any of the device got failed, then the entire FCAL network will be impacted. So every device must be in healthy state. Okay, then only the FCAL topology will work efficiently. Or else it will impact. If any device failed in FCAL topology, then it will impact the entire network. Okay. Okay, yeah, fiber channel hub exists. It's okay, just eliminate it. So fiber channel hub, hub is nothing but it is a kind of device which contains multiple ports. Right? We'll be having spike or plug box in home, so that we can connect multiple phones or multiple laptops or to that plug box. Hub is a kind of same similar device where it will be having multiple ports, and you can connect multiple servers or storages to this hub, and you can establish the communication. So that is what they are saying. A fiber channel hub exists to connect multiple devices together. Okay. The FCAL follows 8-bit pattern of addressing called ALPA. Okay. So if when you connect any device to a fiber channel arbitrated loop network, by automatically the device will get an address called ALPA, arbitrated loop port address. The size of the address is, it is a 8-bit address. Okay, with the help of that address only, every device will be able to recognize the other device within that FCAL loop. Okay, but I mean, we will be able to identify the devices by their name, but internally they'll be not able to identify each other by their name. Okay, whenever you added the devices to the FCAL loop, an 8-bit address will be assigned to the devices. Okay, with the help of 8-bit address only, each device will be able to identify the other device. Okay, and they'll use that 8-bit address only for communication as well. Okay, and only 127 devices are supported, as the rest of them are affected by positive and negative volts. Like in single FCAL loop, you can place only 127 devices in a single loop. That is the maximum number. If you want to keep more than that, if you want to add more than 127 devices in a single FCAL loop, then maybe those devices will be not able to perform IO operations properly, and it might cause a performance issue. The 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 more you add devices to the FCI loop, it will be, I mean, the more it will increase the latency, because if this device want to communicate with this hub, then it has to go through this entire loop, right? So it will be increasing latency. For example, I have added one more device in between these two, then it has to go through three devices to establish the communication. That is the reason. Okay, they recommended you to add only maximum of 127 devices in a FCI loop. Okay, and here the device which has the 00 has the highest priority and reserved FC. It's okay, just leave that. Okay, so there are limitations too in FCAL. FCAL shared bandwidth in a loop. Only one device can perform IO operations at a time. Yeah, FCA if if when you are connecting your devices to FCIL, FCIL is using shared bandwidth. It is not a dedicated bandwidth. Okay, just in switched fabric, it is a dedicated bandwidth, but FCIL will share the bandwidth in the loop. So that is the reason FCIL will not give a good performance like a switched fabric. Okay, because in switched fabric, it is dedicated. The speed is dedicated. Okay, and here they're saying one more point, like only one device can perform IO operations at a time. That means uh, I, I told you earlier, these two devices can communicate with each other, right? At a time, maximum two devices can communicate with each other, but only either this server will perform IO operations to this device, or this device will perform IO operations on this device. Like only one device can perform IO operations, another will receive the IOs, right? That is what they are mentioning. Each device in a loop has to wait for its turn to process an IO request. The speed of data transmission is low in FCL topology, right? As I told you earlier, each device has to wait for its turn to process the IOPS. Okay, so the latency, the speed of the data transmission is very low in FCL topology. FCL uses 8-bit addressing. It can support only again they're repeating the same points again and again. Adding or removing a device to the loop result reinitialization, which can cause a momentary pause in the loop traffic. That means if you want to add a new device to the FCL topology, or if you want to remove a device, like you are decommissioning a server, you want to remove it, then we need a downtime. We need to take a maintenance window for that. Okay, these are the limitations of FCAL. Any questions, guys, on point to point and FCAL? Okay, then third topology is switched fabric. Okay, switched fabric. Let me see that I have a diagram which I used to show when explaining switched fabric topology. Okay. Okay. So let me draw it one more time, no problem. So here we'll be having servers. Let's assume this is a switched fabric topology. Okay, let's assume I'll be having multiple servers in here. Okay, let's assume I have three servers, and on storages also I have two. Assume that I have two storages. Okay, and here what we'll do, we'll configure at least minimum two SAN networks. Okay, SAN networks. These are SAN. We can call them as fabrics. That is the technical name. Okay, fabric. SAN network technical name is fabric. Okay. Whenever I mention fabric from now onwards, just consider it as a SAN network. And in each and every fabric, we'll be having multiple SAN switches. So with the help of multiple SAN switches, what I'll do, I'll establish a SAN network called Fabric. That means here, if I have multiple SAN networks and I created a SAN network, then it will be switched fabric only. Okay, I'll be using multiple SAN switches and creating a SAN network with those multiple SAN switches. Then it is a fabric. I mean, that is a switched fabric topology. Okay, so will be every organization will follow the same standard, like everyone will maintain two fabrics, because if one network will goes down, still clients, servers and storage will be able to communicate with each other through the second SAN network. That is the reason everyone will maintain at least two SAN networks in each and every data center. And as I told you earlier, every server will having at least one HBA. So servers will be connected to our SAN networks. Okay, so yeah, these will be connected to our SAN networks. Okay, through HBAs. The same way, my storage is also will be connected to SAN networks. Yeah, this is how they'll every each and every device will be connected in switched fabric. Every device will be connected to uh, redundant SAN networks. So if my entire network goes down, still my server will be able to communicate with storage with the help of another SAN network. Okay. For example, let's assume uh, here, let's assume these are two HBAs. If my one HBA went down, still my server will be able to communicate with other HBA to storage. For example, my one of my fiber channel went down, still FCA adapter went down, still my storage will be able to communicate with the servers through another FCA. Like that, everything is redundant in switched fabric topology. That is the reason among these three fiber channel topologies, every organization will prefer to use switched fabric only. Okay, most of the organizations will go with switched fabric only. I never saw point to point or FCAL in any of the organizations which I worked. Okay, everything is switched fabric. Now let's go through here. Also, they explained in the same way. Just it is not like that you must maintain two SAN networks. It is, if you want redundancy, you'll be having multiple fabrics. But even you can form a switched fabric you if you have a single switch also. Single here in this diagram, they have only single switch, and their servers and storage everything is connected to single switch, and this is a switched fabric topology, like that. Okay, so fabric is a well designed, intelligent and self configurable network that follows FC standards. So fabric is a well designed, that means uh, you saw, right, if any component fails, still there will be communication between server and storage. Like if one HBA fails, I'll be having another HBA. If one SAN network fails, I'll be having another SAN network. If one FCA fails, still my storage will be able to communicate with servers through another FCA. Like we'll be using redundant things in switched fabric. That is the reason we'll call it as well designed and intelligent. Why we'll call it as intelligent? Because it can do things on its own. That is the reason we'll call it as intelligent. And self configurable in the sense of, for example, I have a port in this switch where I connected a server. Then what it can do, it can change its ports type and port configuration on, okay, according to the device connected to that particular port. That is the reason we'll call fabric as a self configurable. Okay, and network that follows FC standards. FC fiber channel protocol have it has some standards, but Among these three protocols, only switched fabric will follow those standards and will satisfy those standards. Okay. It is called self-configurable because the ports of the fabric are intelligent software specific, that they configure themselves according to the devices connected to them. I have already explained it in the first point itself. So if you connect a server, then to the fiber channel switch port, then the port will be configured. Port will configure itself based on the device connected to it. If you connect another switch to the port, then it will change its configuration. Okay, it can detect the device which is connected to that port, and based on the device it can configure the port on its own. It can change the port properties and port configuration on its own. Okay, next. FC switch is also referred as fabric connect logical phase. It's okay, let's leave that. Oh my god. Okay, in a single fabric we can in a single fabric, 1 to 239 switches can be kept. Like, that means I told you, right? We'll be forming a fiber channel network, SAN network, by multiple switches, right? Like that, we can keep up to 239 switches in a single fabric. You can form a fabric, you can form a single SAN network with maximum of 239 switches. But I don't think that none of them will be going with that huge fabric, because the highest fabric which I saw is 12, I guess. That is the highest one which I saw. I don't know, maybe any of you have seen a very big fabric, but theoretically you can place 239 switches and create a fabric. That is the maximum. If your fabric has 239 switches, then you can't put more than that. You need to create another fabric, another SAN network, like that. Okay. And each switch in a fabric will be assigned with a id called domain id. Okay, 1 to 239 domains, as each switch has its own domain id. Okay, each switch has its own domain id. Like, in a single SAN network we'll be having multiple switches, right? So each switch will get its own id. We'll call it as domain id. With the help of domain id only, one switch will be able to identify the other switches with the help of domain id. Okay, they'll be able to communicate with each other with the help of domain id address only. Okay. Fabric can also include hubs and tape libraries. Blah blah. We can include hubs also, but we don't do it naturally. Okay. So switched fabric addressing. 1 to 239 switches can be placed in a single fabric. Again, the same point. Every switch is identified by domain number, and up to 239 domains are available in a single fabric. That we have already discussed about it. And the addressing pattern followed in a switch is 24-bit address called PID, port identifier. Like, when we discussed about FCIL, whatever devices connected to FCIL network will get a address, 8-bit address, right? We'll call it as ALPA, arbitrated loop port address. The same way, if you connect any device to a switched fabric, then the device will get a 24-bit address called PID, port identifier. Okay, so the devices within the SAN network will be able to identify each other with the help of this PID only, this 24-bit address only. Okay, and theoretically, up to 16 million devices can be connected to a fabric. So theoretically, for example, you have created a SAN network with 239 switches, with high-end 239 switches, then you can go up to 16 million devices. Okay, 16 million devices. That is the maximum you can go. But 16 million means it's very huge, right? I don't think that no one will touch that mark. Okay, practically 16,000 devices are connected within a fabric. I mean, Facebook or some company, they have connected 16,000 devices in a single fabric. That is the maximum which someone went practically, but theoretically it is 16 million devices like that. Okay. Any questions, guys, on fiber channel topologies, point to point or FCAL or switched fabric? Okay, then yeah. WWNN and WWPN, right? Each and every HBA or FCA will be having WWNN, worldwide node name, and each port on top of HBA will be having WWPN, worldwide port name. Just they'll explain to you like what are the standards, how the address will be, everything they explained. I'm not going through it. Okay, you'll be able to understand if you just read it. Okay, next let's talk about fiber channel layers. And fiber channel layers also I'll not go in depth because it is a very big concept. Okay, it will take a lot of time and it is a separate course. Brocade itself, it is a separate course actually, Brocade fabric. Okay, it will take a plenty of time, but I'll not cover everything. I'll cover whatever we need in our real-time environment, like to work, whatever we need. I'll explain those things only. Okay, fiber channel layers. So I think if you have studied BTech, you might have gone through OSI layers, network layers. There will be 7 layers. Uh, okay, you'll get the topic in your computer networks, I guess. Okay, OSI layers. There will be 7 layers in network like that. They explained you the same way. In fiber channel also, we'll be having 5 layers. The first layer is FC0, which we'll call it as a physical layer, and second one is FC1, which we'll call it as encoding and decoding. It is not, sorry, it is not 8 by 10 bit. It is encoding and decoding layer, which will be having multiple encoding and decoding. Like we'll be having 8 by 10 bit, and another one is 64 by 66 bit, I guess. Okay. Third layer is FC2, which is framing and flow control. Fourth layer is FC3, which is a common services, and FC4, fifth layer is which is a upper layer protocol. Okay, these are the layers. And if you go to interview, they may ask you like what are the fiber channel layers, and they'll ask you their names as well. But I don't think that they'll not ask you to elaborate the functionality of each and every layer, because many of SAN admins also don't know the functionality of each and every layer. But if you want to do high level troubleshooting on fabric, you must know the functionality of each and every layer. But again, I'm not going to cover the functionalities of layers. Okay, because as I told you, it is a very big topic. Okay, if you are interested, just go through this document, and if you have any doubts, just reach out to me so I can explain it. Wherever you'll be not able to understand, then I'll explain it there. Okay. Next, maybe and one more thing which is important is a frame structure. Okay, so in networks, how data will be traveled? Data will be traveled in a packets, right? For example, if you copy any file, then that file will be divided into small packets, and it will travel over a LAN network in the form of packets, small packets. The same way, in SAN also, whatever data we are copying, it will be traveled in the form of frame. Okay, like for example, if you ping something, what it will do, it will send empty packets to the destination. Okay, and yeah, it is the response time like that. It is sending empty packets. The same way, I think if you use -L option, something. See, now I'm sending 20 bytes size of packet to the destination. The same thing like that. I mean, packet sent, re- 4, received 4. Like I have sent 4 packets to google.com, and it received. And how long it took? It took 52 millisecond, 50 first for the first packet to reach to the destination, and 55 to the second packet, like that. It will send in the form of packets data in normal LAN network or whatever it is. But in SAN network, data will be sent in frames. Okay. So what is here, every frame will contain same structure. Okay, every frame will be having same structure. So the size of the frame will be 2148 bytes. That is the standard size of the frame, and each frame will be divided into five parts. So the first part is SOF, that means start of frame, which will consume 4 bytes in 2148. Okay, in 2148 bytes, 4 bytes will go for start of the frame. Okay, start of the frame will occupy 4 bytes. Second one is header. Header is nothing but it is a where our metadata will be stored. Like header will contain the control information of the frame, like what frame has, where it is going, like everything, like whatever metadata information will be stored in the header. Next, payload. Payload is nothing but it is the actual data where I mean payload is the actual data in the frame. Okay, whatever data we are transmitting from source to destination, payload will contain the data. So the, sorry, header size is 24 bytes and payload size is 2112 bytes. And CRC. CRC is a it is a kind of authentication mechanism, cyclic redundancy check. It is a two-way authentication technique. Like whenever you are sending frames from a source to destination, it will do two-way authentication, and it will send the frames after verifying the authentication from source to destination. Okay, and the CRC size is also, it is a 4 bytes. And next, last one is end of frame. End of frame indicates that this frame is end, this frame ends here, so again you will get a new frame, like that. Okay, it is also 4 bytes. End of frame has, the size of the end of frame is 4 bytes, though. So in total it is 2148 bytes, the total frame size is. Okay, any questions, guys? These two are very important, like fiber channel layers, and you need to by heart these names, and frame structure also. They may ask you in interview. Okay, any questions? Okay, then let's discuss few things about switches. Today everything is theoretical, so I'll talk about practical things like F loggy, P loggy, process loggy. Cisco. Second one is Brocade, Meg Data. I think McData and Cisco they got merged, I guess. So, okay, these are the three vendors which will provide the SAN switches. I think we have one more called Juniper. We have few more, but nobody will. I have never seen the. I mean, those SAN switches anywhere. Okay, most of the organizations will go with a Cisco or Brocade only. Okay, Cisco or Brocade. Everyone will use these two vendors only. In that, many organizations will go with a Brocade. Okay, Brocade is a market leader in SAN switches manufacturing. Okay, so in this course also we'll talk about Brocade. So Brocade categorized their switches into two two categories. They have divided the SAN switches into two categories. Okay, so the first one is director level. Sorry, director level switches. Second one is department level switches. Okay, these are the two categories. So director level switches are nothing but these are very big switches which contains I mean, they can give you more performance and they'll be having more ports. Okay, and the bandwidth also, data flow, everything is very high. Okay, director level switches, the best examples for director level switches are like 12K Brocade, 12,000, 24,000, 48,000. But these are old models. Okay, these three are old models, but the latest ones in director switches are DCX, DCX 4S. Okay, 4S, DCX 85104, DCX 85108. Okay, these are the director level switches which are available in Brocade. But these 12K to 24K and 48K, these are old models. I don't think that you'll be able to see them. You'll get a chance to work on them. You'll not get a chance to work on them. Like most of the companies will be using DCX series only if they have a Brocade environment. Okay. When it comes to department level switches are very small switches. Okay, like for example 5100 or Brocade 300, like that. Okay, the department level switches are very small switches which contains less port number and less port speed. Okay, and when it comes to performance wise also, they when you compare them with director level switches, they'll be having everything less. Okay, now let's discuss about the architecture of director level switches, how they will be, and what are the internal components. I don't know deep dive. I'll explain you like what I know. Okay, because I didn't get a chance to see a level switch directly. I do. I have seen normal switches, department level switches, but I didn't get a chance to view the director level switch. Okay, so basically, director level switch will be, it is having a chassis. Okay, it will be having a chassis, and in this chassis, it will be having multiple blades. Okay, we can install multiple blades in this chassis. Let's assume I'll explain about DCX series. One, three, four. Okay. So let's assume these are the blades. Okay. So these two are will be having two blades called, we'll call them as SP blades or CPU blades, which contains the management port, which contains a ILO port. ILO port means nothing but it is a port which we can directly connect our laptop with the help of cable, and you can manage the switch and you can do initial configuration. Along with that, it contains a processor, everything, motherboard, everything will be there. They'll be having two blades of this kind, because if one blade goes down, still another blade with the blade will manage the can manage the entire switch. Okay. And along with that, we'll be having two more blades called ICU ICL blades. Okay. ICL blades. So ICL blades are for, they'll be having a dedicated ports. Okay, they'll be having dedicated ports where you can use these ports for to connect to another switch. Okay, you can use these ports to connect to another switch. Like for example, I have one more DCX switch. I want to connect them together and form it as a single fabric. So what I can do, I can connect these ports in my switch 1 to ICL ports in switch 2. Okay, so that these two switches will be able to communicate with each other, and they will behave like they will be in same network. Okay, previously I mean, if it is 12K, 24K or 48K, you will be not having these ICS ports, dedicated ICS ports. That time it is little different. I'll explain you later how then without ICLs, how we used to connect, establish the connection between switches. That is a different. But in DCX, they have you know added these blades for switch to switch connectivity. ICL means inter chassis link. Okay. So next, whatever remaining, all these are port blades. Okay, all these are port blades. We'll be having, I guess, four port blades, four, 8 port blades totally. Okay, the full switch contains the same way here also 4 port plates. Okay, so these port plates contains the actual ports, actual fiber channel ports. Okay, so to these ports only we'll connect our servers, storages and all. Okay, and again, each port, I mean, these ports will be divided into small groups. We'll call them as port groups. Okay, we call them as port groups. Okay, so this is one port group and this is one port group. Okay, so in the background we'll be having a component called ASIC. ASIC. The full form of ASIC is uh, integrated circuit. Anyone remember the full form of ASIC? Asymmetric integrated circuit. Hello. Application specific integrated circuit. I googled it. Application integrated circuit. Okay. So this is a kind of processor, okay, which will be in the background and which will give compute power to the ports in our port blade and port group. Okay, based on the ASIC only, we'll be having, I mean, like a port speed and everything will be decided based on the ASIC. So it is a like a kind of a processor which will give compute power to the ports in our SAN switches. Okay, so that's it, guys. We'll be having multiple port groups in a single port blade, and like that, we'll be having multiple port blades in a single switch. Any questions? If you're good, then I'll show you some diagrams which are related to these DCX switches. Yeah. Okay. So so yeah. So yeah, this is my DCX switch. Okay. So this is the total chassis, and in that these two are SP blades or CPU blades. These are for only for management purpose, and it contains some ports like ILO port, management port, and all it contains. And whatever here, uh, these two, these are ICL blades, okay, inter chassis link blades, okay, which will use to establish the connection with one switch to another switch. And remaining all are port blades. See, this is the entire thing a one port blade, second port blade, third port blade, fourth port blade, like that. And this is one, this is a single port group again, and this is another port group, like that. Okay, this is how the DCX switch looks like. Okay, and the advantage with these director level switches is you don't need to buy a full switch. Okay, based on your requirement, you can buy. I don't need the total 8 port blades. What I can do, I can buy a. See here, if you see this diagram, see, this is a director switch. Okay, maybe DCX series. Yeah, D685108 switch. This is, and they have only these much port requirement. So what they can do, instead of buying a full switch with a full capacity, they bought a full port blade here, and here they they bought 2 port blades with 3 port groups each, like that. Based on your requirement, you can install the port groups and port blades, and you, and if you have a requirement to connect few more servers and few more storages later, you can purchase a port blade or port group, and you can install it later. You can do configurations like that. That is the advantage of having director level switches. But you purchase a department level switches, you won't get this kind. You can't do like this, because they don't have any chassis or blades. It is a single switch which contains everything in that. Okay, so let
I
me show
think
you.
we can buy the blades, but we cannot buy the port groups. So the
uh,
the blade comes with a
department switches. So department switches are small switches. Mm, yeah, just like this. So they don't contain any chassis and anything. Everything like ILO, a management port, and fabric sand ports. Everything will be in a single container. So there will be no option. Like if you ran out of ports, then you need to buy another switch. There is no option like increasing the ports, like a director level switches. Okay. Any questions, guys? Okay. If you are good, then I'll wrap up the session for today as well. Because sorry, I'm at my hometown and yeah, I can't take network is very low here. I'm using my mobile data, so I'll not get sufficient data for to perform my office work. That's why only this week only. But again, next week I'll take 1.5 hour class. It's which means yeah, edge switch means it is a department level edge. I'll talk
Yeah,
about core edge topology also. Yeah, edge switch is department level switch. Core switch will use director level switches. Yep.
sure, sure.
Thank you, guys.
Okay.